All right, so this idea of definition of division, okay? And we know that A divided by B is equal to C if B times C is equal to A, all right? Now, there's one thing here, we can do this with a lot of things, but let's try this. Let's say 8 divided by 0 is some number. We'll call it x. Okay. If what?
If 0
times x is 8. Okay. Now, what can you tell me about this? It's impossible. That's right. Because what do we know? Anything times 0 is 0. Right, all right. So since this is impossible, okay, dividing by 0 does not fit the definition. That's why we say that division by 0 is undefined. That's why we say it, because it doesn't fit the definition. Does that make sense? Okay. So one of the big things we're going to be looking at in the course, okay, is are we dividing by 0? We've got to make sure that we don't. Okay, so stick this idea away for when we begin talking later on about ideas of domain. All right, just as something to clue you in for further work. Okay, so we've got this definition of division there. All right, so let's see what can we do with this. Well, let's see. Suppose I have, let's see, some examples here. 2x to the 5th over, 5, y to the 4th, okay, raised to the 3rd power. This is going to, what do I need to do then? Well, now what is this saying? To the 3rd power means I'm multiplying this by itself 3 times, right? Okay, and so I'm going to have 2 to the 3rd power. That's going to be 8, okay? And this is going to be what? 15, okay? And it's not x to the 8th. This is not an addition situation. This is, remember, this is saying x to the 5th times x to the 5th times x to the 5th, right? So that would be x to the 15th. Thank you, 125, because that's 5 times 5 times 5, and this would be y to the 12th. Okay, that's not too bad, is it? No. Okay, so let's see. Let's try another one here. Let's see. Okay, so Okay, what do you think I can do here?
Cancel the
All right, first of all, we're never going to use the term cancel, all right? We are going to instead use another phrase. We're going to use remove common factors, okay? This is what we're going to use instead of cancel, okay? Because when dealing with fractions, I can remove common factors, that is in a multiplication sense, right? But I cannot do it in an addition or subtraction sense. And I've seen people try to cancel inappropriately, you know, they just get to this slash and burn mode. Okay, well, we're not going to do slash and burn here, okay? We are not aborigines. And I mean, you know, living at that lower level. We're going to be a little more sophisticated here. I really would like to throttle the person who started the trend of using cancel, because it has ruined a lot of people in dealing with fractions. It really has. It's caused a lot of damage. So I never use it. Okay, well, let's see here. Now, think about it this way, okay? We've got like things that we can work with, right? Okay. And so if I was to, well, let's just see, what would happen if I expanded this all out according to the definition? Now, we're not going to do this each time when we do these problems, but we are going to show you why things work this way. So let's see. This is negative 2 times 2 times 3 times 1, 2, 3, 4, 5 x's times y over 2 times 3 times 3 times x times 1, 2, 3, 4, 5, and 6 y's. Okay, there, all right. And we, of course, understand that anything divided by itself is 1, right? So let's see, anything divided by itself is 1. Anything divided by itself is 1. Anything divided by itself is 1. Anything divided by itself is 1, okay? And then I can take a look at what I've got left. What do I have left? I have negative 2, negative 2x to the third, and then I have
3y to the 5th.
3y to the 5th. Okay? Now, there's just from expanding the whole thing out. Well, take a look. Could we do this directly? Well, now, sure. Negative 12/18 is negative 2/3. Okay? I have 5 factors of x here and 2 factors of x here. If I remove 2 factors of x from each, removing common factors, okay, I have 3 factors of x left in the numerator. If I remove 1 factor of y from each, I have 5 factors of y left in the denominator. Not bad, is it? Okay. And so, again, you can see why that works. Time flies. Okay. So let's try another one. And let's see, we've got Now, when you do these things, of course, I want to see your work, you know, step by step. I don't want just to see an answer pulled out of there. Okay. Oh, there are a few of them that I can see that you would be able to do it in your head, all right? But something like this, do you think I would be expecting you to just do it all in your head? No. You know what happens to the person who tries to eat a whole ham sandwich in one bite? He chokes, okay? And have any of you ever choked on a math problem because you tried to do too much at one time? Very probably. Yeah, okay. So here we go. And well, there are a couple ways we could approach this. Any suggestions? Okay, so you're saying put the negative, you know, apply that, and I would be applying this rule right here, right? Okay, so we could do that. So let's see, I'll put that up here. So this is 4 to the negative 2, what?
P to the negative 4.
P to the
Negative 4.
negative 4,
Q to the negative 2.
Q to the negative 2, over what?
6 to the negative 2.
6 to the negative 2,
P to the negative 2.
P to the negative 2, Q to the negative 8, okay? And does this look like a mess? For some people it does, okay? Well, now let's see. The thing is that we don't like to have negative exponents ever hanging around, right? Okay, so I've got to do something here. Well, we could, but I'll tell you what, remember anything? Well, okay. What is a to the third times a to the negative 3? 1. Why did you say that? It's a to the 0, which is 1. Very good, okay? In other words, these two things are what kind of numbers? I'm going to give you a hint. Multiplicative inverses. What's the name for multiplicative inverse? Reciprocals. That's right. These are reciprocals. Okay. So I guess what I can do is I can think sneaky here, and I've got more negatives here than I've got here, right? So I need to get 4 p's up here to get rid of the negative p's, right? And 4 p's down there would give me 2 p's altogether, wouldn't it? So essentially I'm going to be multiplying by p to the 4th over p to the 4th, just, okay? So I'm not changing the value as long as I multiply by 1, right? Okay. Now let's see, the q's here. My mama always said to mind my p's and q's. What do you see as a possibility for getting rid of the negatives here? Okay, taking care of the negative 8. What would I need to do then?
Q to the negative 8. I mean Q to the 8.
Okay, so I multiply numerator and denominator by
Q to the 8.
q to the 8. Okay. So here's this. Okay. And we'll take care of this in, well, we'll take care of this in just a moment here. Okay. Actually, I can take this onto this side and that onto the other side. So that would be 6 squared over 4 squared. Okay. And so let's see, that's going to be no p's and
6 cubes.
6 cubes. Okay, so 36, 6 cubes. And this is going to give me, come on,
2 p's.
2 p's. and no q's, and 4 squared is 16. Okay, and I can divide each of those by 4, so that would give me 9 fourths q to the 6th over p to the 2nd. But that seems like an awful lot of work for that problem. Okay. Well, now, I believe in the KISS principle. Okay, you know what the KISS principle is, don't you? Keep it simple, stupid. Yeah. Okay. And if you take a look in here, I've got some stuff in here already that could make my life easier. So, let's see, 4/6 is already 2/3, right? I have 2 p's here, 1 p there. I can remove a p and p in the numerator. Okay. I have 1 q there, 4 q's there.
Q to the third in the denominator.
Q to the 3rd in the denominator. Okay.